No, I just stopped off on that tangent. Let me see, 23. So I'm 24. I'm over half. Okay. We're about at 50% capacity. Not sure how to feel about that. I feel sad. Actually, I think the last time I looked, we have 38 people that are still with us. Not meaning anybody passed away; they all just dropped. So I'm down 14. So any other questions on homework? We looked at a few things, but anybody just log in, have any questions from homework stuff?
I have a question on assignment 3.6. I know we haven't covered it yet, but number 36 on 3.6.
3.6. We basically did. But 30, yes, okay. Beautiful. This is actually, I think, is it still up here? Yeah. Okay, we were talking about this earlier. But this is good for everybody to hear because 36 is definitely a freaky one. So let me show the problem. I think everybody should be able to access their book, but just to show it real quick. We're talking about this one here, right? Oops. That one, the one about the A, find the A that makes it have no x-intercepts. And then you think to yourself, how the shit do I do that? Well, okay. So let me redraw this stuff here. Do. So they give you this. What are we able to control ourselves about this function? What's the control we have? What's the control they give us?
A.
A. That's all I can change, right? Don't tell me that x could be numbers. Right. The x can be all the numbers. I can't affect that. All I have control over is what A is. What kind of shift would this represent for this function?
That's an upshift.
Or down if A is negative. You with me? So it's up or down because it's outside. Yeah. What kind of shift is this? This one. Left. How does it absolute value of x? How does that one shift it?
Left or down? Or no, I'm sorry. Left or right? Right?
Left or right, sure. Yeah. Narrow it down a lot more.
It goes left one.
It goes back one, left one. I like it. Because again, I used to have to put a 0 in to get 0, but now I have to put a -1 in to get 0. So all my inputs get 1 less, so it shifts it back. So when it's inside with the variable, it does the opposite of what this says. Because that's kind of like the variable reacting to that. Oh, you're going to add 1 to me? I could be 1 less than I used to be then. So the whole thing moves back 1. When it's outside, it does exactly what it looks like. It's going to move the whole thing up A. All right, that's great. Ooh, Jeff, how does that help? I don't know. I'm just wasting time. No. What if I made A 0? What would this look like? Where would the turning point be?
-1 on the graph?
-1, 0, right?
-1, 0, right. Just kidding.
And then it does shit after that. Who really cares? It goes up and it has, this is an x-intercept, that's a y-intercept. So 36 says, what would this have to be that'll make it have no x-intercepts? So what if A was -1? So I get this equation. What would that do to this graph?
Shift it down 1.
Yeah, so if I shift it down 1, now all of a sudden, how many x-intercepts does it have?
2.
Holy shit! Damn it! I was supposed to make it have none, and I just doubled it. But now you should see the answer. How do I make it have no x-intercepts? Don't say anything. The answer should be staring at you. Don't say it. Don't say it. That's all I'm going to do for you. It's basically done. That's number 36. If you just came in the middle of that. Now I'm only down 8 people. All right. Someday I'll have everybody here. Maybe on a quiz day, everybody will be here. for the final exam. That's when I see all the people and think, who the hell are you? Anything else from homework stuff, guys? Homework. I got that I'm a Creep song in my head for some reason. I'm a creep. I'm a weirdo. What the hell am I doing here? All right. Nobody knows that? Radiohead? That's right. Sorry, I'm old. Shut up. All right, I'm not seeing any of the questions, so I'm gonna get into my shit. Anybody? Nobody questions? Questions?
Actually, I have a question.
Yes.
So when you're finding the inverse of an equation, and
Ooh, we haven't done that yet. I like it.
oh, we haven't? Wasn't that 3.7?
That we haven't done yet.
Oh, I did the 3.7 homework.
I like it.
When
What's
you're
your question? Because I'll come back to it when we get into it.
Yeah, when you find the inverse and you get, like, you switch x and y and then you get how you have to take the square root and you know how it's plus or minus. You have to choose whether you're going to keep it as the plus or the minus.
Oh, so they must have restricted. No, so you started off as a square root, right?
Yeah, like, because
Okay,
when you're solving, yeah, you have to get the square
Hold
root.
on to that question, because that is going to take some lecturing to get to the point where we can really do that problem, but that's a good question.
Okay.
The thing to realize is the square root of x has a restricted range, right? Do you see what I mean? Doesn't the square root have a restricted range?
Yeah.
Yes. And when you find the inverse, you switch x and y, which means the range and the domain switch.
So then there's so there's restrictions for y as well.
Well, yes. I mean, that's the range. So there's restrictions on the range for sure. Right. So anyway, we'll come back to that. We'll come back to that because that's a little bit deeper into the discussion. We haven't even started the discussion. Okay. So what I want to do first. Any other questions? I live off of questions, and you should live off of answers. So you want to have a lot of questions. But absence questions, I'm going to do this. So if you are able to, can you log into Canvas right now? I have uploaded a worksheet. And I'll show you right where it is in a minute. Pop. So if you go to modules and you scroll down, there's unit 0, 1, 2. Here's unit 3. Hey, look at that. That's new. All right, so I just want you to have this. So what we're going to do is we're going to talk about inverses, and then we're going to come back and do this, this sheet. So I just want you to have that at the ready, right? So at some point, log into Canvas, go get that sucker, and be ready to work on it. So let's talk about inverses, and then we'll do that sheet. Okay. I don't belong here. All right, so here is the kick-ass thing about inverse functions. I like to start the discussion of this graphically. But you're not used to starting with the graphs of things, but it's awesome. I'm going to start there because we're crazy. What has to be true? Remind me, we already know something about inverse functions. What must be true about a function? You already know this. What must be true for an inverse to exist? The function must be what?
1-to-1.
1-to-1, kick ass. Which means it must pass the
horizontal line test.
Horizontal line test. I love it. So if I wanted to graph a function that will pass that test and have an inverse, think about what that means. This is kind of neat. There's a neat word I'm going to use that you don't have to know, but I'm just going to tell it to you anyway. Why the hell not? if I have a function, let me be very, very precise here. It's important when you copy this, you're very, very precise. So say I start here. What point is that? Okay, like it. What point is that? Can you guys see that all right?
-3,
Yeah.
-4.
I should look at my, yeah, because here it looks fine, and then I go over here and I'm like, oh shit. Yeah, so -3, -4, is that cool? And then if I go, let's say I go where, Jeff? Let's say I go here. So that, of course, is -2, 0. Can I go this way and still make this kind of a function?
No.
I have to continue going up. So there's a neat word is called monotonic. That doesn't mean that you're only drinking one kind of drink. Monotonic is, it's like monochrome is one color, monotonic is one direction. And not the band. All right, listen. So monotonically increasing means it's never flat or decreasing. So then I can go like over here. And that, of course, is the 0.01. That's amazing, Jeff. And then let's end up here. And that, of course, is the 0.23. And then my function is very funkadelic, like that. So it's like a three-piece, piecewise function. Is that cool? We're not even worried about the function itself. There's the graph. That's all I care about. And that is obviously invertible because we forced it to pass the horizontal line test. Now think about this. What does it mean to invert a function? And why does it correspond to this horizontal line test? For every x, there's a y. And for every y, there's an x. So this function is what, it takes the x's and does stuff to them. So the inverse must do the opposite exactly. And see what I'm doing with my hands? It must take the y back to x. So if this function goes through the point -3, -4, the inverse must go through the point
-4, or 4, -3, or 4, 3. There we go.
-4, -3. It doesn't change the signs. It just flips them around. So for example, are these inverse functions of each other? I don't know why I put the parentheses there, but are those inverses? You can do it.
Yeah.
Not at your question.
Yes.
Yes.
Yes, because one undoes the other one, right? This goes to the point what? 2, comma, I'm sorry. Jeff, that's evil. This goes to the point 2, comma what?
8.
2, 8, all right? This one, of course, goes to the point 8, comma
2.
2. Huh? I mean, wouldn't that happen always? Any function that is the inverse of another one is always going to have its points reversed. Let that make sense. Does that make sense? That's what inverse functions do. They undo. So this function made 2 become 8. This function makes 8 go back to 2. That's why it had to be 1 to 1, so that it can always go back to where it started. I'm always looking at Amber because she's the only face I can see. Can more of you, let me try this. Can anybody else turn their camera on unless you're in a compromised position or something? I mean, obviously. Look at that. Oh, man. I'm thinking about just making this sort of an almost requirement because I'm going to go a little insane.
You just have to ask.
What's up?
All you have to do is ask.
No, you're right. You're right. That's why I'm asking. You're right. And I understand that sometimes you cannot. Oh, Joshua's in a compromised position. I understand. We don't want to see that shit. So you keep your camera off. That's fine. All right. I appreciate that. All right. I got 2 rows of faces to look at now. Thank you. Okay. So how can I graph the inverse? So if this is f of x, how am I going to graph f inverse? It's remarkably lovely and easy. F inverse, what points will F inverse go through? We already got one of them. What other points will it go through?
0, -2.
0, -2.
1,
And
0,
1, 0. And
3, 2.
3, 2. And then you just plot those. So -4, -3. Well, Jeff, there you go. You see it from your perspective. -4, -3, and then 0, -2. Let me see, I'm watching the camera, so oh yeah, that one's easy. 1, 0, and 3, 2. That should be good, right? Yes. Now look at this cool shit. You're gonna have to admit this is cool. When you connect those, what kind of symmetry do you see? Do you see any symmetry? Like where would the mirror be for
It would
this?
be along y equals x.
Why does that make a ton of sense? Because how did I make the red line? By switching x and y.
X and
So
Y.
they flip over the y equals x line. That's so kick-ass, right? Doesn't this look like Nazca lines or something? Anybody know the Nazca lines? All right, look it up, kids. Jeez, what the hell? What do they teach you in school? Oh, yeah, inverse function, sorry. All right, that kicks so much ass. I'm hoping somebody out there agrees with me. So that's all you have to do. If they give you the graph of an invertible function, say graph the inverse, that's all you have to do is turn all the points you see around. Don't change the sign. That's not what inverses do. Okay. All right, so watch this. Let's continue this awesomeness. Has everybody got what they want from all of this? Okay. So how does this translate algebraically? So that's the graphical way to do it. Somebody kind of gave it away earlier, which is fine. All right, Jeff, it's all right, dude. I got to get every single thing. Stop it. All right. If they give me a function, how do I find, and I think I used this symbol already, but you guys understand this is the symbol for inverse. This does not mean flip. That is the symbol for inverse. So f inverse of x is not 1 over this. That makes no sense. So I'm going to differ a little bit from what the book says, because I'm not going to be able to stop myself because this is the way I've always done it my entire life. Where's y?
F of x.
Good. Okay, so let's bring y back. Then we do exactly what we did graphically. We switch the x and y. And I always put a little line here. This is just me. You're not going to see another teacher do this. I always hated this step because I'm not doing something algebraic. So this line says I'm applying an idea. I'm not like doing something algebraic, because you're not just allowed to switch the x and y whenever you want to, right? You don't have to do that line if you don't want to, but I'm just going to always do it because that's what I'm used to. And then you solve for y. And I really want this to make the most sense ever. As you solve for y, what kind of operations will you be doing? So what's the very first thing you do to solve for y?
Cube both sides.
Yes, you wouldn't do this. Please tell me you wouldn't do that. Because that wouldn't do shit for you, because you could never get in there anyway. Get out of there. You got to cube both sides. And so am I not collecting all the opposite operations? So of course I'm going to end up with the function that does all the opposite shit in the opposite order. This is too awesome. I know I'm a little extra amped about inverse functions. Oh well. I love that. That gets me excited. It's awesome. I got a great life. I just do some of this shit and I'm like, yeah. God, I'm extra weird today. All right. And then, so I do this. And then, of course,
R4.
check. And then the very last thing I do is I bring in what this really represents now. Now here's where things get really nifty. And that's a 4 down there, right? Poor little 4 dude. I'm sorry. How can I verify that these are inverses of each other? What should they do to each other because they're inverses?
Cancel out.
They should cancel out. When I do what though? So if I do this, can you guys take a minute and simplify this. Do that. Go. So this is that composition stuff we learned. Take the f of x and shove it in there. And as you do that, I'm going to go get some liquid. I have no liquid at all. I need some. So I'll do f inverse of cube root is 4. So now that'll be x cubed, that'll be this thing cubed minus 4. And of course, what happens here?
They cancel. You get x plus 4 minus 4.
Which is x. So fundamentally, what did these two do to each other? Kill each other. So how do you verify that two functions are inverses? You plug one inside of the other one. And if it comes out to x, that means that one undid the other one. Let's be a little more specific. What is f of what, Jeff? I don't know, 23. What is f of 23?
Three.
Yes, because you get cube root of 23 plus 4 is 27, so you get 3. What is f inverse of 3? Taking that output. If you do it, 3 cubed is 27 minus 4 is
23.
Oh, I can't, holy shit, oh, holy shit. Right? Maybe. Not at all. Like some of you guys, I can see your faces now, so this is good because now I see some of you guys are like, you think you're funny. You ain't. Just do math, math boy. All right, I'm sorry. Okay. So with that knowledge we have now, is that bad? Is that hard? What's really beautiful is the same idea carries graphically, algebraically. Switch the x and y. So let's look at this handout. Have you guys all gone to that handout? Handout. Have you heard? Let me see. What have I taken today? So if you logged in after I talked about this, the handout, if you can, access Canvas, go to modules, and right after unit 0, there's the unit 3 module, and this is new. This one right here. Bam. I know it says logs on there, but I'm not putting logs on there yet. Don't worry. So I just want you to do these. So it's a combination of composition of functions and then inverse of functions, right? So the first 3 are composition, the last 5 are inverse stuff. So is anyone not able to access Canvas and requires me to show this up on the screen? Anybody? Is anybody in that? It's fine if you are, you just have to tell me or else I'm gonna stop sharing. Is anybody not really here right now? Can you raise your hand? I'm joking. I don't know. All right, so everybody, I'm gonna stop sharing then because nobody said they needed it. Go ahead and do that sheet, get started, and then I'm gonna break you out in the room so you can all sit there and not talk, and then we'll we'll do it together. Hopefully there's some talking that happens. Here, I'll stop recording for now. All right. All right, lady. Jeez, interrupt much. I think I got around to all the rooms and showed you the whiteboard thing. Is that true? All right, I think so. All right. Here. Let me spotlight me. Oh, so let's take a look at this sheet. Holy sheet, where are you? You are right there. Okay, good. Let me share this. Oh yeah, I gotta change the, you guys go over there. You guys come over here. Oh my God. Okay, technology, I love it. Bam, bam. All right. So, oh, let me break this bad boy out. Yay. So, I'm hoping that the first few were not a major issue. So another way to write this, of course, is like this. Please let me know if you have any questions about anything. So I'm just going to plug, I always start from the inside out, 2x minus 1 into h. It's going to involve a little bit of work. So hopefully you actually did a little bit of work. So I got to plug 2x minus 1 into h, so right into place. So that'll be 2x minus 1 squared minus 1. And if you do that foiling, you get 4x squared minus 4x plus 1 minus 1. That's awesome. Is that what you guys got? Good.
No, I got.
Go ahead. Sorry.
I said I
Never
got a
know
different
what
answer, but yeah, I know what I did wrong.
Okay. Because I could always make a mistake. I am open to that possibility. I'm not one of those asshole teachers that say, I never make a mistake. Shut up.
You don't have to pull out the GCF to make it like 4x times x minus 1?
No, because factoring is actually the opposite of simplification. And what I want here is simplification. I like it. All right, so now g of h. So now I'm just going to plug that bad boy into g. And there's only a little tiny bit you can really do here. Here's the first place where people can make a mistake. You got to put this in the place of x, and it's minus the whole x. So it's minus the whole thing. So then you get 1 minus negative 1 is 2. So that's what you should end up with. How do we do on that? If you didn't get that, do you see why you are wrong?
Yeah, I see why I'm wrong.
Okay. Thanks, Brian. That's why it's good to make mistakes. I mean, holy shit, if you don't know something, you're going to make mistakes. When you make a mistake, you learn. It's amazing. Yep. And then this guy is a little bit easier because I can start with g of 9. I could plug a 9 in. 1 plus the cube root of 1 minus 9. And of course, the cube root of negative 8 is?
Negative 2.
Good. So now I want f of negative 1. And so I just plug a negative 1 into f. And it looks like I get negative 3. I did that one that kind of quick. Is that all right? I'll take that as a yes. Okay.
Yep.
Yep. Okay. And then we come down here. Here's our first little inverse problem. Inverse of f is not going to be a big problem. I bring y back, right? That's what we're doing. We're bringing y back. Then you switch the x and y. And the book says do that last. I'm just, my whole life I've been doing that first. So I'm not going to change now. And then you solve for y. And you get that. It's amazing. Or however else you want to write that, right? And then you just replace that with f inverse. So again, the original function subtracted 1. This one adds 1. The original function multiplied by 2. This divides by 2. Ah, it's the opposite. Okay. And then g inverse, this is going to be a little bit more interesting. So just to cut to the chase, I'm going to write this, if everybody's cool with that. I'm going to skip a couple steps. Oh my God, dude. You little pen, you. Okay, there you go. What's the very first thing I should do here trying to solve for y?
Subtract 1.
Subtract 1. 11. Subtract. If I cube, that would so desperately suck. Because then I have to write this whole thing 3 times. Oh my God. So I want to isolate the radical first so that my power only acts on it. Does that make sense? Because then they kill each other. So now I get x minus 1 equals the cube root. Now I do what?
Cube.
Cube. And please, dear God, if it's a squared, I expect you to do it. Anything higher than a squared, don't waste your time. Some of you guys are like, I wish I would have known that earlier. Well, you know, too bad. And then just to cut to the chase a little bit, I'm going to add y and subtract this shit. Is that okay? So I end up with 1 minus this business cubed, and that's the inverse.
Can you scroll down a little?
Yeah, I will. Is that all right? You guys, I skipped a couple steps at the end, but right, add y, subtract x minus 1 cubed, and then replace y with f inverse. Okay, maybe. And now, how do I do g inverse of 0? Well, here, oh, sorry, it should be a g here, shouldn't it? It was g we're talking about. So that should be a g right there. I should keep it straight myself. So how do I do g inverse of 0? I just put a 0 in here. Let me stop there for a minute. Is everybody cool with that? I know what the g inverse function is now. So I know how to do g inverse of 0. I just plug a 0 into the g inverse function.
Yeah.
Now some of you guys are going to understand number 3, but I'm going to do this step by step. So just hold on to a shortcut if you got one. So this will be g of 1 minus negative 1. And then what's g of 2? Well, here's the g function basically. 1 plus the cube root of 1 minus 2, which is 1 minus 1, which is 0. So of course it did exactly like we knew it should. They killed each other and left you with 0. Let me stop for a minute. So we already knew what the answer is going to be. We should have known what the answer is going to be because we know what inverse functions do to each other. It's just nice to see it happen. All right. Everybody okay with those? This is funny that this is actually better compared to when I just had the mouse, this writing. So I'm not going to apologize. That's just too bad. You picked bad. You picked poorly if you wanted a teacher that could write legibly. So let's do this in a different color because it's already sort of blue down there. Let's do red, blood red. Okay. So what points will my inverse function go through here? What points will it go through? This is the point.
-8, -10.
What?
Negative
All right, so this
seven.
point,
Negative 10, negative 7.
so then it's going to go through -7, -10. Then it's going to go, this is -5, 0, so my new one is going to go through.
5, negative 0.
No.
I mean 0,
0,
negative 5, sorry. I had it backwards. Huh?
And then this one is 5, 5, right? Yes. So if I turn that around, I get 5, 5. And then this is, where am I at? Here it is, 7, 10. So mine is going to go through 10.
7.
Yeah. And we already know basically what it's going to look like because of the mirror image thing, but you know, this just makes it more precise. -7, -10. Looks to be about right there. 0, -5. Kabam. 5, 5. Hey, it's already there for me. That point is on the mirror. And then 10, 7 is right there. Good, buddy. I'm sure 10, 7 means something. Then you got shoop, shoop, shoop. And it always looks like some kind of weird little bug to me, but all right. Okay. And number 3 is not connected to any other number, but it's the easiest problem on here. Well, almost easy. The other one would have been easy. But what happens?
They cancel each other out, so it becomes A.
Done. It doesn't matter what the F is. What the F is. It doesn't matter. Because this problem assumes there's an F, there's an inverse F. So what are they going to do? They're going to kill each other. So then you're left with the inside. I love it. Kabam. All right. Let me see what time we got. It's about time. It's probably about time. Yeah, what the hell? Sounds about good. Anybody? We basically finished chapter 3. Chapter 4 should be quicker than the 2 days I have allocated for it, but we'll see. I'm not going to rush through it. It is mostly linear. I keep looking this way because you're all on this screen now.
Professor.
Hello, camera. I'm not used to looking at you because I'm not a YouTube person.
Professor.
Yes.
Can you go over that square root thing I was asking about?
Oh, yeah. What was it again? It was
Like problem 15 on the homework. 3.6.
so is it something like
No.
this
It
or
was
something?
Like f of x equals x squared plus 2, like something like that.
Oh, so then they give you what else did they say?
And it wants the inverse. And so when you do it, you get like y equals plus or minus the square root.
All right, so let me look at it because they are not giving you enough information if that's what it is. Let me stop sharing for a minute. Let me take a look here. What was it? Which problem again? I'm sorry.
15.
15. Let me see.
You'd have to restrict the domain, right?
Yes. Find a oh, it does. It says part of the problem is find a domain on which each function is one-to-one and non-decreasing. I love that. You would, Jeff. So let me share this. Let me see. I got so much shit open on here. This is insane. I can't believe my computer has not died. Let me move you guys over there. Let me share this. All right, so here's the problem. Right there, this one. But it says, find a domain on which each function f is one-to-one and non-decreasing. Can somebody please help me? Shit. There it is. Okay. And you're all like, I'm not qualified to help you, Mr. Waller. I'm sorry. Oh, I can't even do this, can I? Oh, God. If I do this, can you guys still see the book if I do shit and a half? Hold on. I know. Old man trying to work it. I know. Hold on. Just stop. Okay, how do I make you stop? Okay, can I take it now? Yes. Can you guys still see that book? Oh, shit.
Yes.
You can?
Yeah, I can see it.
Neat. Why does it say my screen share is paused? Weird. Okay, what
I
the
see the
hell?
book, but we can't see any annotations or anything that
Oh,
you're
here we
doing.
go. Now it's going to work. Okay, now I got it. That only took like too long. Okay, here's the problem we're looking at right there. Let me use my fuchsia. Somebody just gave up on me and left. I understand. Find a domain on which the function is one-to-one and non-decreasing. Can somebody very quickly tell me what this looks like, the function itself, if I graph it? Don't just say u. That's a little too quick. Maybe a little bit more description. Where will the vertex be for this?
0, 0.
No.
Oh, wait. No, you got the negative 5, so it's going to be 0, 5.
Go
Yeah.
-5.
Yeah, and then it's going to go up from there. It's roughly going to be a little bit past 2. It doesn't really matter that much. All right. So the main thing is, this is what it looks like. No, not really, but oh well, you get the idea. God dang it, Jeff. What are you? Anyway, it doesn't matter. That's it. So what is it doing here? Is it increasing or decreasing?
Decreasing.
Decreasing.
That's not what it wants. So what part are we going to kill? It has to be one side of the turning point, right? Because it doesn't pass the horizontal line test because of the mirror image. So if I kill one of these two sides, it will be invertible. And it wants me to have it non-decreasing. So of course I'm going to kill this side. So now my function is this one. Let me make it all official. Let me come in here with, there it is. That's my function right there. Is that invertible, that black line?
Yes.
Of course, it's one-to-one now. But what's the domain?
0 to infinity.
Yes, I love it. And then it says, now I can find an inverse for this. Now watch what happens when you try to find an inverse. So I'm going to switch these two. I don't want to do too much work for you guys. You already know what this should look like. It should reflect around that line. So this one goes through 0, -5. So my new one should go through
Negative
-5.
5, 0.
So it's going to look like this, right? So is it going to be the top part of a root or the bottom part of a root?
The top?
Yeah. So when you do the square root, you don't put plus or minus because you already know it's got to be the
Top part.
top part, the plus. Yeah. Do you
Yep.
guys see how that connects? I really like that problem because they didn't restrict the domain for you. They made you restrict it. I like it. That might be why I chose to assign that one months ago and I forgot what it was about. Okay. I think that's probably enough. I almost finished the problem for you, so I think I should stop right there. Anything else before we head out? Or, I mean, I'm going to officially end class now, so you can head out if you want to. If somebody else has a question, feel free to ask.
Could you go back to the practice test, please? I forgot I need to see something really quick.
All right, hold on. Let me see. Where are you? There you are. Okay, let me share this one.
Thank you.
You're welcome. This guy, Brian?
Yeah, I'm still kind of confused with the number. I believe it's E.
Oh, this guy.
Yeah.
So I did exactly the same steps I did here. I switched the X and Y.
Mm-hmm.
Right now this is Y. So then I switched the X and Y. Bam. And then I started solving for Y. So I isolated the radical. I subtracted 1. Because now I can attack the radical directly by cubing both sides. So that kills that.
Oh, okay, and then you're just left with 1 minus Y. Okay.
And then I just added Y and subtracted. These just change places then. That's the beautiful thing about algebra.
Okay.
Okay.
And then for D, for D, that's a negative. That's X plus 1 over 2, right?
Yeah.
Okay.
Or it could be 1/2 X plus 1/2. It doesn't matter either way.
All right. Because for that one, I initially got just a half, but I didn't get the X plus 1.
Ruh-roh. Yeah, because right here you add 1 to both sides. And there's an X over there already. Yeah.
Yeah. Okay.
Cool.
Alrighty.
All right. So tomorrow, the few people I have left, I do want to look at finding like an inverse for something like this. Jeff, why are you using your mouse again, dude? I don't know, man. There was a problem sort of like this earlier. So I want to find the inverse for this. So we'll do that tomorrow. Yay! And then we'll get to chapter 4. Yeah! All right. Any other questions?
Nope.
Jason says, enough for me. I understand. Okay.
Oh, tomorrow. Sorry. Tomorrow I'll be working up in Oceanside, so I will probably be on a little late. I will be missing like a couple minutes because it's like I'll be getting off at 3:30, so it takes me a little while to get home.
Oh yeah. All right. That's okay. Get in here when you can.
Alrighty. Either way, I can access the recording, right, on YouTube.
Yep. Yep.
Okay.
Cool.
Alrighty. Sounds good. Thank you, Professor.
See you. The rest of you guys okay?
Yes, bye. Have a good night.
Bye-bye. All right. I'm headed out. I don't see any questions.
All right.
Good night, everybody. Bye.